All right, today we're digging into something pretty radical. It's the blueprint for Project Umoja Kabong in Uganda. And when I say radical, I mean a plan to build a totally self-sufficient energy system literally from the ground up. So let's get right into it. The whole project really kicks off with this one core idea. Think about it. For places that have so much potential, but just don't have reliable infrastructure, well, that foundation for growth is shaky at best, right? You're totally dependent on a fragile power grid or super expensive imported fuel.
So, what's the answer? How do you build a new, solid foundation? That's the huge question this project is trying to answer. And the idea isn't to just slap a patch on the old, broken system, no way. It's about designing something brand new, something that's literally rooted in the very land it's going to power.
The old way of doing things, it's just a one-way street. You extract resources, you use them once, and then you just discard them. It's a linear model, and it's not just wasteful, it's also incredibly fragile. Any little shock to the supply chain and the whole thing can fall apart. Project Umoja, it's here to replace that entire mindset.
And here's the replacement. It's called a circular model. Basically, it's a closed-loop system where the concept of waste just doesn't exist. There are only resources that haven't been fully utilized yet. Pretty cool, right? Let's break down how it actually works.
Okay, the whole thing is basically one continuous loop, broken down into 6 stages. Think of this as our roadmap for this explainer. We're going to walk through every single step, from literally planting a seed in the ground all the way to powering an entire industrial park, and then, get this, returning the nutrients right back to the soil where it all started.
So, stage 1. Where does it all begin? Well, it's not with drilling for oil or mining for coal. Nope, it all starts with agriculture. It's about growing the fuel, and not just any crop, but one that actually pulls a massive amount of carbon out of the atmosphere.
And here's the fuel source itself, hemp hurd. It's the woody core of the hemp stalk. Now, the key number you need to know is its energy value. Independent university research has confirmed that this stuff packs a serious punch. We're talking 15.72 megajoules per kilogram. So this isn't just a random idea. It's a scientifically validated, high-quality fuel.
And just to give you a sense of the scale we're talking about, that initial kind of smaller bridge power plant, the 1 megawatt one, well, just to fuel that, they need to harvest from over 1,800 acres of industrial hemp every single year. So yeah, we're not talking about a backyard garden here. This is a massive, integrated agricultural engine.
All right, so the hemp is harvested from the field. Where does it go next? It goes right to the technological heart of the entire system. This is where the real magic happens, turning this simple plant material into clean, reliable electricity.
But, and this is a big but, it's not easy. Not at all. Look at this image. It's a lab-scale gasifier from the research done at the University of Modena. It does a fantastic job of showing just how complicated this whole process is. Turning biomass into a clean gas fuel, it's called syngas, by the way, is this incredibly delicate balancing act. It's just really, really hard to get right consistently.
In fact, that same academic research pinpoints 3 huge challenges that pretty much plague all of these kinds of systems. Number 1, you have to control the moisture down to a T. Number 2, you've got to maintain this perfect air-to-fuel mix, something called the equivalence ratio. And number 3, the big one, you have to deal with tar. It's this sticky, gunky byproduct that will absolutely destroy your equipment if you let it.
Okay, so the real question is, how does the Umoja system actually solve these problems? Let's take them one by one. First up, moisture. The solution? A dedicated piece of kit called the feedstock processing unit. It's basically a massive rotary drum dryer, and its only job is to make sure that hemp hurd is at a perfect, consistent moisture level, we're talking less than 10%, before it even gets close to the main reactor. Now what about that second challenge, the one that research paper literally calls very hard to set? Well, the answer here is pretty futuristic. It's intelligent automation. There's a central control module that uses AI to watch dozens of variables all at once, and it's constantly making these tiny micro-adjustments in real time. The goal? To keep that crucial equivalence ratio locked in at the perfect level of 0.3 all day, every day.
And this is such a great visual for what we're talking about. These 3D graphs come straight from that university study, and they show that the sweet spot for peak efficiency and maximum energy output, it's in this really, really narrow window. The AI's entire job, its whole purpose, is to keep the system living right on that bright green peak, 24/7, and never letting it slip down into those less efficient valleys.
And finally, we get to the tar problem, the big one. How does this system solve this? Honestly, with brute force physics. The plasma gasification core runs at over 5,000 degrees Celsius. Let me say that again, 5,000 degrees. At that insane temperature, those sticky tar molecules, they just can't exist. They're instantly ripped apart, vaporized back into their basic elements. And just like that, you solve what the research paper calls the main problem that afflicts gasification.
Okay, so we've got clean, reliable power. Awesome. But what about the leftovers, the byproducts? Well, remember, in a true circular model, there's no such thing as waste. So let's look at how they close the loop.
Everything that comes out of that plasma process is captured and gets a new life. The stuff that's left is this inert, glass-like slag. They crush it up and sell it as a high-quality material for building roads and making concrete. And the carbon-rich ash and char, that goes straight back to the farmers. It's an incredible soil amendment. And boom, the circle is complete.
And that, right there, is the core philosophy in a nutshell. It's a system that was designed from day one to make sure every single output has a valuable purpose. This isn't just about being green. It creates multiple new revenue streams and completely eliminates the idea of waste.
Okay, let's zoom out for a second and look at the bigger picture here, because this is so much more than just a plan for one power plant. What we're really looking at is a strategic blueprint that could have absolutely massive implications. Of course, a project this big, this ambitious, it's got huge potential, but it also faces some serious challenges. The upsides are obvious, right? We're talking complete energy independence and the ability to tap into carbon credit markets. But the risks are just as real. It costs a lot of money to set up, and you're completely dependent on a good harvest, which, as we all know, is increasingly at risk because of climate change.
So how do you manage those risks? Well, you do it smartly. The rollout is really practical and done in phases. They start small, just powering the construction site itself with solar panels. Then in year 2, they bring that 1 megawatt bridge plant online. And that plant then provides the power to build the final 10 megawatt facility, which goes live in year 5. I mean, they're literally building the future with the power of the future. It's brilliant.
And this quote from the project's own documents, it just perfectly captures the whole vision. It's not being sold as just a business plan for a power plant. It's framed as a promise, as a blueprint for a sovereign, prosperous, and self-determined future. It's about a whole new way of thinking about economic development.
And that really brings us to the final, and maybe the most important question of all. If a community can actually grow its own power, what else can it build? When you achieve true energy sovereignty, when your power is local, it's reliable, and it comes from your own land, that becomes the foundation for everything else. It's a question with some pretty profound implications, and not just for Kabong, but for communities all over the world.